Hello everyone, I'm Professor Harrison, and welcome back to our module on regression for finance. Today we're going to be covering the R-squared. It's a standard way that we measure how well a regression fits the data. Today we're following Margot, a graduate student trying to reassemble a story that her family buried. Today she's looking at a fund whose returns mostly move with the market. She wants a single number for how much of that movement the market actually explains. She turns to the next problem in her coursework. So far we've been building regression lines and interpreting their coefficients. The natural next question is how good the line actually is. R-squared is the number that answers that. R-squared is the proportion of the variation in the outcome that the regression line explains. To get there, we need to think about the variation in three pieces. Start with the total variation in the fund's returns. We measure that by taking each month's return, subtracting the average return, squaring the difference, and adding it all up. That total is called the total sum of squares. It's basically how much the fund's returns bounce around their own average before we bring the market into it at all. Now bring the regression line. For each month, the line gives us the predicted return based on where the market was. Those predictions also vary around the average. We take each predicted return, subtract the same average, square it, and then add it up. That piece is the explained sum of squares. It's the part of the bouncing around the line accounts for. And then there's the line misses. For each month, the gap between the actual return and the predicted return is the residual. We saw residuals back when we set up OLS. Square each residual and add them up, and you get the residual sum of squares. That's the variation that the line does not explain. Here's the part that makes all this work. When the line is fit by OLS and includes an intercept, those last two pieces add up to exactly the first. The total sum of squares equals the explained sum of squares plus the residual sum of squares. So the total variation splits cleanly into the part that the line explains and the part that it doesn't. R-squared is just the explained piece as a fraction of a total. So R-squared equals the explained sum of squares divided by the total sum of squares. And because the three pieces add up, that's the same as 1 minus the residual sum of squares over the total. So both versions give you the same number. Since the explained part can't be bigger than the total and can't be negative, R-squared always lands somewhere between 0 and 1. So let's put some numbers on it. Margot's regressing a diversified fund's monthly returns on the market's returns. She runs it and the total sum of squares comes out to 100. The explained sum is 75 and the residual sum of squares is 25. Notice that those add up. 75 plus 25 is the 100, exactly like they should. R-squared is the explained piece over the total. So that's 75 over 100, which gives us 0.75. We could also do it the other way and do 1 minus 25 over 100, and we end up with the same 0.75. So 75% of the variation in this fund's returns are explained by the market. And that has a nice clean reading for finance. 75% of the fund's ups and downs come from the market moving. The other 25% is the fund doing something on its own, separate from the market. That leftover 25% is the idiosyncratic part of the fund's returns. Now here's the thing that people get wrong about R-squared. A high R-squared tells you that the line fits the data well. It does not tell you that the model is correct. And it does not tell you that the market causes the fund's returns. Fit and truth are two different things. And a low R-squared doesn't mean that the model is wrong. Think about a fund that's making big concentrated bets on individual companies and mostly ignoring the broad market. If you regress that fund onto the market, you'd expect a low R-squared because most of what it does has nothing to do with the market. That low number isn't a failure, it's telling you something about the strategy. One more connection is worth making. That residual sum of squares is exactly the quantity that OLS minimized when it picked the line of best fit in the first place. OLS chose the slope and the intercept to make that leftover as small as possible. So 1 minus the residual over the total is really measuring how small OLS managed to make the leftover compared to how much variation there was to begin with. Margot writes the numbers down. For this fund, the market explains most of the story, but not all of it. She's going to be comparing a lot of regressions as she goes, and R-squared gives her one clean number to put to each one. So that's the R-squared. We split the total variation in the outcome into the part that the line explains and the part that it doesn't, and R-squared is just the explained part as a fraction of the whole. It runs from 0 to 1, and it measures fit, not correctness. A high value means that the line tracks the data closely. It doesn't mean that the line is true or that one thing is causing another. That distinction ends up mattering a lot when we start using regressions to make claims about the real world.